Well, spring has sprung, much better weather, gotten a lot of the projects done I needed to do before we started this garden shed, and I am in full swing now putting up this arched A-frame Styrocrete garden shed. And this is an amazing way to build out of 85% recycled material. It is cheap, but you get a wonderful quality house. And I am finding easier and easier ways of how to build, trying to figure out cheap ways that we can put up quality houses that look great, well insulated, and will last a lifetime. Styrocrete, the more I'm working with it, the more I'm seeing the huge potential in what this stuff can be used for. And you can recycle it, furniture stores, boat places. I mean, everyone's got styrofoam that they're throwing away. And you just run it through the shredder and you've got mountains of this stuff that you can build houses, B&Bs, workshops, garden sheds, and even insulate pools, pool houses. It's just unlimited. If you can make a form for it, you can cover it, fill it up with this stuff. Now, this project, my last project was the workshop, and I did the walls, 5.5 inches thick. I made forms that I set up and then poured it from the top. So this was solid Styrocrete walls. Then I covered with the fiber mesh, and I stuccoed it 2 coats. And it's really, really strong. It's holding up a 2nd story and a roof. Now, I'm not recommending that you build with that. I think I'm pushing my luck with that, with the compressive strength of this stuff. I mean, this styrofoam held together with Aircrete. But Styrocrete is shredded styrofoam that you mix with Aircrete, which is Portland cement that you mix with a foam that looks like shaving cream. And it makes a very aerated, insulated mix. And then adding the styrofoam, you really, really get a well-insulated light mix. And it's very, very easy to work with. Aircrete can be finicky and collapse on you, and it doesn't. Of the shredded styrofoam, that's my mix for a load. These sections here, 4 feet wide by 20 feet long. This workshop is 12 by 20 garden shed, and it's taking 5 loads to do 1 section. Now, I'm doing this in a 3.5 inch wide wall. I'm not needing tons of insulation here. It's a garden shed. It's not even a workshop. Keep my lawnmower, which is electric lawnmower, and we want to keep the battery from freezing, so that's important. And I've wired the wall already before I even poured it, which is wonderful because you got the gaps in the trusses, and you just run the wire and put up the boxes, and it was really, really easy to wire this 1 section. I'm going to put a couple more receptacles in the back wall. And then I'm going to have a 6-foot door here, double door, cedar door to open up to bring in the lawnmower. And I'll have a light switch right here for the wire. And I've got power coming from the workshop that'll come in right here into the shop to give me power. The biggest change that I'm doing from how I did the workshop to this is to build with trusses. And this is really making a big difference. What I found with the workshop is if you need to tie in a wall or put a plate on the top, you got nothing to nail to. Styrocrete, you can put pins all deep into it, and that's what I had to do, is to drill holes and drive stakes with glue into the mix to be able to get a bond. But a tie in a wall is very tough because it won't take screws. When you put in the trusses, now you have things to nail to. And this is now becoming my frame. Building the wall panels and putting them in and drilling holes and screwing them to the concrete, using turnbuckles to adjust the level and run lines to make sure you got a perfectly straight wall before you ever pour. It takes a lot of time. You pour it, and then you got to take all this down. You got to clean the molds, oil them again, put them up in the next section, and pour again. Those forms are really heavy. They're like 100 pounds a piece for a 4x9 panel that I would made out of 2x4s with OSB on the inside. I painted them inside and out so that they would hold up against the weather. OSB does not like water. You've got to really protect that, and same way with this hardboard. This is a hardboard that has the white surface on it, kind of like a white marking board. And this stuff doesn't like water either. And so I painted both the back side of this, and I'm being very careful here. Hopefully it'll survive multiple pours. I've got to do 6, 7, maybe 8 pours total with these boards before I can throw them away. They're up to $22 a sheet right now. It is ridiculous what building materials have skyrocketed to. Thankfully, Portland cement has not climbed a whole lot. Yes, it's gone up a little bit, but nothing like 2x4s that are 9 feet for a stud, and OSB 4x8 sheets that are $48 a sheet, and we wrap the entire house in these stuff. And then 3/4 inch flooring is $64 a sheet. I mean, this is ridiculous. I did a cost comparison of building with this versus conventional, but that was before the prices went sky high. I mean, it would be like $6,000 difference now. A little over $1,000 will build this 12x20 workshop, garden shed. But the arched A-frame design, I wanted to do the entire building out of the Styro Aircrete instead of just the walls. And because the beauty of this is if you've got an insulated area all the way around, you got all this area under roof that is all insulated. Makes it so much easier to work with. You can have ductwork up in the top level here, and it's not and it's inside of the insulated area, and so it's not sweating. And if you've got leaks in your ductwork, it works wonderful. Now, if I was building a B&B, for instance, out of this, I would go with much thicker walls. I would go at minimum of 6 inches, but going 8 or 10 would make a lot of sense depending on where you're building. And it's not costing you a whole lot of money to extend and widen the wall. The expense is the fiber mesh and the stucco that's going around it. And, you know, as far as the trusses, they're going to be pretty much the same. It's just larger blocks in the middle of your pieces. So that's what I would do if I was doing a B&B or, mother-in-law suite or building a house. Now, the arched A-frame design is a very efficient design. It gives you more room than just the straight A-frame. Having the arch makes it a stronger structure, and it gives you better room all the way through the building, and it's easy to build. Now, I built a jig. I had some of my sheets left over from my 4x9 panels from doing the workshop. Put them up on sawhorses to make me a nice table, and the radius of your circle is 12 feet. So from here to here is 12 feet. And then you strike a line and 12 feet on either end, and that's where you're joining at the top. Now, this is giving me about 11-foot high ceiling in this thing. And you strike the second line, and then that is going to be your pattern for the jig. You then take small blocks of wood, and every 24 inches you nail a block. So here's the jig. So it's going to be like a piece here and a piece here every 24 inches. And I've got blocks every 24 inches, but they're going to be screwed on between those blocks. And so the first time that I made a jig and built an arch, I just used one band on either side with a block in the middle. And I tried to do it with 1 inch, but bending it to a 12-foot radius, it snapped. You've got to go with thinner strips to be able to bend it that far. So I ripped it all the way down to a 1/2 inch, and I'm doing 2 layers on either side, on either side of this to hold it. And so you take your 1/2 inch ripped board, bend it into the arch, and you'll typically have to piece 2 pieces together to get your full 13 feet or so that I was going here. Then the next piece you glue. So you apply glue to the second layer, and you put the two together, and you use lots of clamps, and you clamp them every 24 inches to those blocks and pull them in tight all the way around there with glue between them. And then you do the second two strips and you bend them into the jig, and then you brace them and grip them to the left side, to the other side with braces, clamps all the way around. And then you come with your little blocks, whatever block size you are. It's going to be thicker if it's a 6.5, 8.5, but these are barely an inch thick, inch and a quarter, or my blocks, to make an exact 3.5-inch wall. And I put glue on either side of those, drop those in every 24 inches. And anywhere that I had splicings of the 1/2-inch pieces, I dropped another block in there to help support that break. And then I took my nail gun, and I've got galvanized nails that I used for this, and nailed the blocks, 2 nails in each side, on either side, went all the way through the jig, got to the other side, nailed it all the way to the other side. And then I got my little brad nailer, and with little 1-inch brad nails, and I went along between the blocks to nail the 1/2-inch pieces on either side that were glued, and pop them all the way through there, and you're done. Well, I say you're done. Then on the end, I cut the ends off, and I've got a little notch on the bottom right here where it fits down on the ground. I've got a little notch on each one. So I had a block at the end, but about an inch away from the end. So cut it off nice and level. And then the top part, I cut it at the right angle where these two halves are going to be coming together. It took me about 25 minutes per arch. Now, white wood does the best. When you rip white wood into 1/2-inch strips, pine is harder to bend, and it also has more knots in it, and knots are not your friend when you rip it into 1/2-inch pieces. They will crack and break. So there was a couple of pieces in there I couldn't use because of the knots. But you can take scrap lumber, and all of this was out of dumpsters from building houses. And you take the wood pile from one framed house, and you will have plenty of wood to make all of these trusses and then some. And you just run it through your saw, ripping them 1/2-inch pieces. And a 2x6 will give you about 8 strips of 1/2-inch pieces. So if you are building this, and buying the wood, just buy 2x6 10-foot long and just rip them, and you'll get lots of strips out of them. So each truss has 4 1/2-inch pieces with the blocks in the middle. But because of the small block size, you can use all of the waste and chop them up into these small pieces. It is a really powerful way to utilize all your waste and build you a wonderful structure. Then on the ends over here, I ripped a board exactly 1 1/4 inch thick, just the thickness of the blocks that were inside this thing. And it runs, treated piece runs all the full length. And I put some liquid nails underneath it to glue it to the concrete. And then I shot nails through it into the concrete. And it's like a .22 caliber gun that shoots the nail into there. This concrete was really, really hard. It was hard to drive those nails in. They weren't even going in all the way, but I did get some penetration within the glue, and it glued it solid all the way down. That then was the piece for my trusses to sit on. And one by one, I would build my truss and put 2 halves down on the ground. And then I had a OSB or plywood plate that I had painted and put on the end that I could screw down to tie these things together, and then popped in screws sideways into it at an angle there to join it right at the tip. Now something else I did on here, and I don't know if I really needed to do this, but I wanted to do it for safety reasons, for long term, that in case we got moisture in the wall and we ended up with rotting going on with these trusses. We're putting elastomeric roofing paint on this. This thing should be nice and watertight, but invariably you're going to get cracks over time and get moisture in the wall. Farmers have used motor oil and diesel fuel mixed together as a great water protector for wood. And they'll paint the ends of their posts, fence posts, and put them in the ground, and they last a super long time. And you can make a mix like this and spray your barn if you've got lapboard siding. It's an oil-based stain, essentially. The diesel waters down the oil just enough so it'll penetrate into the wood. It'll darken the wood a little bit. I had a bunch of old oil and transmission fluid and power steering fluid, and I just mixed them all together. But another more environmentally friendly method is vegetable oil and vinegar. And it's usually 2 parts oil to 1 part vinegar. I was finding I was needing to go more 1-to-1 to get it thin enough. And so I used vinegar instead of diesel fluid. And it doesn't like to mix with oil very well, but you mix it up good and it'll stay mixed long enough for you to use it. And so then I made a little trough out of bricks, just deep enough that I could cover it then with plastic, and made me a trough, and then poured all of this mixture into the trough. And then I was able to run each arch through the mixture and dunk it. And then I would lay it out on the gravel and let it dry. And when it dries, you end up with, first of all, it's a little darker and prettier, but there's a light film. You know, I feel it here, I can tell there's a little bit of oil on that truss. But that will go a long ways in helping to protect this. Yeah, and you can use this on furniture outside, sawhorses, whatever you've got exposed to the weather outside. Put this in your sprayer and put a coat of this stuff on there. Makes for a really nice cheap sealer on your wood. But that is how the trusses are made. And so then once I've got them all tied together, I was able to lift them up, and they're really light. There's nothing to it. Lift it up, and I put stakes in the ground with a post to be able to put the level on there and get it nice and square. And then lifted one by one, and then used some stringer runners to tie them all together as I was going on either side to lift them all up. And in the afternoon I had all of the trusses up, and it was exciting to see the thing take shape. And I mean, it's strong enough I can hang from any of these things and it hold my weight. The issue with building with alternative building is that it's not in the building code. And if you are in a city where you've got to follow the building code, I'm out here in the county and I can build anything I want to. There's no inspections, but not everybody has that luxury. And so when you start coming up with Styrocrete, what is that? We need an engineering stamp on your drawings before we're going to approve you to be able to build with this stuff. Well, to do like the workshop, whether it's pure Styrocrete with stucco mesh and stucco, you got to go to a test lab and be able to build a wall and do a compression test and see how much weight it can hold before the engineer is ever going to put his green stamp on that method of building. That costs a lot of money. With this, we've got trusses. Now we're dealing with wood. We know the strength of wood, and the Styrocrete can hold this building up by itself without the wood, but you add the wood into this and you have a super strong structure. And when you pack the walls solid with this and then wrap it all the way around with fiber mesh and stucco the thing, this thing is going to be really, really strong. It's a monolithic structure where the entire building will be wrapped and stuccoed and tied together. And I really don't think there's going to be a problem getting an engineer to approve this. Once I get finished with this building, I'm going to start talking to some engineers locally about this system of building. Now, I've seen this arched A-frame. There's several videos online on how to build with these things, and a lot of folks are using it for greenhouses, and they'll put them every 4 foot on center or 3 foot on center, and then cover it with plastic. I've also seen some giant yachts where they put some huge ones of these 4 foot on center, and then they'll put a massive tarp over the whole thing, and then they can work on their yacht in the dry. And same system, same way of making the trusses. Now, you could potentially go 4 foot wide if you were using OSB as your forms. I tried bending OSB with a 4x8 sheet here. No way. It is way too stiff. Potentially, though, that I did not try is to bend it this way and see if you could get it all the way up and following the contour of this thing, and I think you could. I think that the OSB would be strong enough if you had these on 4 foot centers. If you had wood stringers like you can see I've done here of top and bottom, and this will give it the support. If you did that every 4 feet with the 4x8 sheets of OSB, I think you could get away with using OSB. Of course, OSB is $48 a sheet, and this stuff's $22, so you go figure. This stuff is easy to work with. It's very flexible and is holding up so far. I'm up to the 3rd pour now with this. But that is the beginning structural frame. I'm going to break this up into different videos, but this first one primarily is how to make these arched A-frames. So if you're not wanting to build with the arch A-frame, you can build with a gable, and you can make trusses for your gable. And so here's your wall. I've made this one 5.5 inches thick, so essentially it's 1-1 with a 3.5 inch block, 2x4 in the middle. And then I've gone 8 inch over here, so now you're using a 2x6 block with a 1 inch stringer, and I've got the roof overhang boxed in. And so you would make each truss, and this is just for show, so it would be taller than this to get your 8-foot wall all the way up to the center, and you'd make, instead of arches, you're making gables. And you tie them together in the middle, and again, you just lift them up the same way that I'm doing with the arched A-frame, but now you're doing conventional walls. And then you would and then you do your, there's 26 of them in here, so 13 altogether. I put an extra one in here for the overhang. So my wall is going to be 6 inches from the end here, so the wall will be right here. And I put an extra one just so I had something to nail to when I join this wall in. So however much you want your overhang, then do an extra truss all the way there. So you're ripping your wood 1 inch on either side and then putting the blocks in the middle. And then you put your OSB on either side all the way down and fill your whole wall solid. And you could fill this whole section solid too. So you'd have OSB here, here, and on the top and here as you pour this whole section solid all the way down in your building. And they'll work great. And that's conventional lumber, and as far as the shape goes, and give you flat walls with a gable, and it won't be a whole lot more work than doing arched A-frames, and make them any thickness that you want, and that should work really well. So that is my first video on the arch A-frames and using trusses instead of just pouring it with solid styro Aircrete. And I think it is going to be a whole lot easier to get this approved through permits and coding, and working with engineers to approve it for strength all the way through as we pour this